Alright, so welcome to Noble Team YouTube channel, and in today's class we want to look into 12 rules in rectilinear motion calculation. Now if you are new to this channel, do well to subscribe to this YouTube channel and also wait for more educational videos, tutorial videos like this. Now without wasting much of our time, we are going to be looking into this class content, which is definition of rectilinear motion, key terminologies in rectilinear motions, equation of linear motion, equation of motion under gravity, and distance in time interval. Then we also have velocity time graph. You understand? Velocity time graph. Now we are going to be looking into this, and this is what we do be looking into. And trust me, I'm going to be solving 20 solid questions. Now this video is not only for JAMB students, it is for YX students, NECO students, and even A-level students, which is 100 level students. Because in your 100 level first semester, you are going to be doing mechanics. Yes, you are going to be doing mechanics, and if you don't have a knowledge of this, it will be very, very difficult for you to cope in what 100 level. Now this video is for both YX, JAMB, NECO, and A-level students, especially 100 level students. Now, my name is Noble C of Noble Team, and we are going to be looking into this. Now, let's move. And we are going to be starting with the definition of rectilinear motion. Now, once you hear about rectilinear motion, what comes to your mind? Now, I want us to take note of this. And before I start, I will urge you to get a pen and a book. Do you understand? Because this is not just an ordinary video. Because I'm going to be exposing some certain points that you need to know. Some certain points that if you search for it in your text, you are not going to see it. Do you understand? Even though you know it. Do you understand? Because there are some questions I might solve, you don't know it. Do you understand what I'm trying to say? So I advise you to get either a headset, any kind of headset or earpod, but just to limit distraction. Now, let's look into the definition of rectilinear motion. Now, once you hear about rectilinear motion, what comes to your mind? Now, I'm not going to be writing. Do you understand? It's not everything I'm going to be writing because we don't have enough space here. Because once we treat from year to year, we are going to be solving questions. Once we treat this particular guy, we solve question on it. We treat this, we solve questions, so it can stick into your memory. Now, I'm going to be defining some terms. Do you understand? You have to write. You pause the video and write. Now, what is rectilinear motion? Now, another name for rectilinear motion is called linear motion. Another name for rectilinear motion is linear motion. Right. Now, rectilinear motion is a motion in a straight line or path in a constant direction. Now, once you hear rectilinear, it's something that is moving in a straight line or in a straight path. For example, this is my marker. You notice that the ink of it is moving in a straight path. Now, this is what we call a rectilinear motion. I hope this is well understood. Now, let's look into the key terminologies in rectilinear motion. Because if we don't understand the terminologies in rectilinear motion, when we start solving questions under these equations of linear motion, you will get confused. You understand? Yes. Now, we have the first one, which is the speed. We have the first one, which is what? The speed. We have the speed. Now, what is the definition of speed? Now, speed is the distance per unit time. What do I say? Speed is the distance per unit time. That is why we have d/t. Do we understand this? Speed is the distance per unit time. Now, the next one we need to define is the velocity, because we need to know the definition of velocity. Now, what is velocity? Velocity is the displacement per unit time. It is the displacement per unit time. You take note of it, which is what? d/t. This one is distance, this one is what? Displacement. It is the displacement per unit time. Now, the next one we need to look into is acceleration. Acceleration. So now, acceleration is the change in velocity per unit time. You understand? It is the change in velocity in respect to time. Anyone can go. You understand? Now, I want us to understand the difference between this particular distance and displacement. You know, these particular two things are not the same thing. I'm going to be explaining it. Just follow me closely. Now, once you hear about distance, this is why we define speed is equal to distance over time. The reason why we define speed is, for example, now, a vehicle. Do you understand? Like you are traveling from Enugu to Lagos. You will notice that the speed, like the distance the bus will be traveling, will be, like the bus will not be traveling in a straight path. There is a path in which the vehicle will reach and make a U-turn and follow another road. Do you understand? That is what we call the distance. No constant direction. Do you understand what I'm trying to say? No constant direction. At a point, that particular vehicle will follow another route. Do you understand? But what we mean by displacement is something that maintain a straight line, moving in a straight path without what? Without bending. That is what we mean by displacement. You understand that two of them are not the same thing now. So make sure you do what? You grab it. That is why you have change in velocity over time. I hope we are done with the key terminologies in rectilinear motion, and we take note that rectilinear motion can also be called a linear motion. So we make sure we take note of this. Now let's look into the equations of linear motion. Now we have about 4 equations of linear motion, and I'm not going to be proving it, since in exam I don't think that they will ask you to prove. You get now, because even JAMB I don't think they'll ask you to prove, so no need of proving it. Now, we are going to be listing the equations of linear motion, and I don't be listing it here, because once we are solving questions, we are going to be referring it to this particular place, because I'm not going to be wiping this until we solve a very good solid question, up to 10 solid questions from this equation of linear motion. Now, let's move. Now, the first equation of linear motion is V is equal to U plus AT. This is the first equation of what? Linear motion. Don't worry, I'm going to be explaining the V. What is V, what is U, what is A, and what is T. Now the next one we have is when we have V square is equal to U square plus 2AS. The second equation of linear motion. The third one is when we have S is equal to UT, then UT plus half AT square. Then the last one in which we have is S is equal to bracket V plus U over 2 multiplied by what? T. Do you understand this now? This is the 4 equations of linear motion that you must know. Now, what is my V? My V simply means, let me use my blue marker. My V simply means my final velocity. My final velocity. Then my U is my initial velocity. Then we have our S. S is the distance. S is the distance. Then our T is the time. You understand now? This is what the parameters are trying, the formulas are trying to say. So grab what is V, what is U, what is S, and what is T. Now let's look into the rules, because we have rules in this particular thing. Now I want us to take note of this particular thing, the first rule. Let's go. The first rule, which is rule 1. Now what do rule 1 state? Rule 1 state that if a body is moving from rest or at rest, it simply means that the initial velocity will be 0. Take note of it. I'm not going to be writing it up. Do you understand? What do I say? I say that if a body is moving from rest or at rest, the initial velocity is what? U is equal to 0. This is the rule 1. Remember, 12 rules. Once you know these 12 rules, you are good to go in solving any question in rectilinear motion. I've stated rule 1. Now, rule 2. Rule 2. What does rule 2 state? Rule 2 state that when a body is brought to rest or brought to heart, this is what I mean by heart, HLT. The final velocity is what? when we have v is equal to 0. The final velocity is what? 0. You take note of it. Now the next one is rule 3. Rule 3. Now what does this rule 3 state? Rule 3 state that when you have a constant or uniform velocity, the acceleration is what? Equal to 0. Now what is this point trying to explain? Constant acceleration is something like this. No, not constant acceleration, uniform or constant velocity. Sorry, uniform or constant velocity. Something that is in a straight path without bending like this. Do you understand? We are going to be seeing more of this when we enter into velocity time graph. That is why you need to follow me closely to the end of this video. Now, this is what I mean by what? A constant velocity. There is no decrease or an increase. This is what I mean by what? A constant velocity. At this point, acceleration is what? 0. Now, the next one I want us to look into is rule 4, because I'm going to be stopping at rule 4 in this particular equation of motion, linear motion. Now, when the acceleration is in a negative path, it simply means that it is retardating or deaccelerating. Do you understand what I mean? If the acceleration is in a negative path, it simply means it is retardating or deaccelerating. These two words must be noted. So I have stated up to 4 rules in this particular equation of linear motion. So the next thing I want us to do is for us to solve questions under this. Do you understand? Now let's solve. All right, now we are done with this. We are done with this guy. Yes, we are done with this. We are done with the key terminologies, and we are done with this, and we are about to solve solid questions on this, because I want everything that we are doing to stick into your memory. Now let's look into question 1. The question will appear on your screen. Now the question says a bird flies at 10 meters per second for 3 seconds, 15 meters per second for 3 seconds, and 20 meters per second for 4 seconds. Then we are asked to calculate the bird's average speed. Calculate the bird average speed. Now in mathematics, once you hear average, do you understand? That's simply asking you to sum up everything and divide. Now, in this particular thing, we need to do what? Solve them one by one. Do you understand what I'm trying to say? And when we are treating these key terminologies, I want us to take note of something, which is unit, which is very, very important. The unit of velocity is meter per second. The unit of velocity is what? Meter per second, which is this. Do you understand? This is the unit of what? Velocity. Then, coming to acceleration, it is what? Meter per second square. So don't misplace these two things. They are not the same. You understand that they are of different quantities having this unit. So don't misuse it, because once you misuse this and use this one in place of this to solve for any calculations, you will end up getting the wrong answer. Now let's know how we can apply this particular question 1. Remember when I said speed, the formula for speed is what? Remember when I said so? Okay, the formula for speed is what? S is equal to distance over time. Remember when I said so? Wait, let me open my phone. All right, when I say that speed is equal to distance divided by time. Now the first one, we have it that a bird flies at 10 meters per second. A bird flies at 10 meters per second for 3 seconds. Now we want to get the what? The distance. Do you understand? We simply make this the subject of formula by getting d is equal to s multiplied by t. You understand? Now we have to solve this into 3, because we have it into 3 quantities or into 3 variables. Now the first one, which is what? 10 meters per second for what? 3 seconds, which is what? 10 multiplied by 3, which is what? 30 meters. This is for 1, and I will name it what? A. Then we have the next one, which is B. and I'm going to name it what? B, which is 15 meters per second for 3 seconds, which is 15 multiplied by 3, which is equal to 45 meters. I'm going to name this B. Then the next one is the third one, which we have 20 meters per second for 4 seconds, which is 20 multiplied by 4, which is going to give us 80 meters, which is going to give us C. We are done. Now we want to get the average of this. They said average of the speed, which is going to be S, is equal to the distance. I'm going to be writing 30 plus 45 plus 80 divided by the time. Now the first time was what? 3, plus the second time was what? Also 3, and the third one was what? 4. Then you sum up this. Once you sum up this, you arrive at the answer. Now let's punch our calculator. Make sure that you are doing what you are punching it. We have 30 plus 45 plus 80, which is what? 155 divided by, this is what? 6, 10. This is what? 6, which is 10, divided by what? 10. And we're having 15.5. 15.15 meters per second. Now let's look into the question to know which one is correct. 15 meters per second. Now you'll be asking me the unit of this velocity is the same thing with the speed. Yes, they are the same thing if you apply the knowledge of what? Dimension analysis. Do you understand? I'm going to be doing the video on that very soon. So it is what? 15 meters per second, which is what? Option C is correct. You can see how I solve this. Once you hear average, you understand? Once you hear average, it simply means summing up the distance and also summing up the time. If you ask to get the average speed, I hope you understood. Now let's look into question 2. I'm going to be solving questions. These are solid questions you might see in your exam. Now question 2. Let's solve question 2. Question 2 says a car travels with a constant velocity of 45 km per hour for 20 seconds. What distance does it cover in this time? So that is why you need to apply those rules that are listed, which is rule 1 and rule 4. We have just treated rule 1 and rule 4 now. And I want us to take note that distance is always in meter. Our velocity is always in what? Meter per second. Our acceleration is meter per second square. So both of them are not the same thing. Don't misuse two of them. Now this question states a constant velocity. Remember when I said when we have a constant or uniform velocity, acceleration is equal to 0. Do you understand what I mean? Acceleration is equal to 0. Now in this question, they say that our velocity is what? In kilometer per hour. Are we going to use kilometer per hour? No. Why? Because the unit of velocity is meter per second. And the next step that we need to take to get this our velocity is doing what? Conversion to meter per second. Now I'll show you the easiest way to convert from kilometer per hour to meter per second. Now this is it. I have it to be. Wait, let me unlock my phone. So I have it to be A. I can represent with it X, B, any letter that I can remember, which is X. This X is the value of the kilometer per hour given to you in the question, which is X multiplied by 5/18. Now let's do the conversion. My X here is what? 45 multiplied by 5 divided by 18. Take note that this 18 is only dividing this. So now let's substitute. We have 45 multiplied by 5 divided by 18, which is 12.5 meter per second. So we have converted. Now we are asked to get the distance in this question. The distance, since the velocity is constant and the acceleration is equal to 0, I'm going to be using this formula. S is equal to d over t. Simple. Why am I going to use it? Acceleration is constant. Do you understand? When the velocity is uniform or constant, acceleration is equal to 0. Making this guy subject of formula, I'll have t is equal to d multiplied by t. Yeah, s multiplied by t, which is the speed. Then I have 12.5 multiplied by 20. 12.5 multiplied by 20 give us 250 meter. 250 what? Meter. Do you understand what I mean? Now, this is why I want you to follow me closely in anything I'm doing, because if you mix any one section with me, simply means that you don't understand. Even though you know it, do you understand? Bend down and learn, because you'll be seeing some questions you cannot solve. Now, the correct option to this is option E, which is what? 250 meter. So just make sure you do what? You recall those rules. You recall what? Those rules. Now let's look into question 3. Once we finish solving solid questions in these particular equations of linear motion, I can beat my chest with full confidence. There is no question you will see on linear motion or rectilinear motion you cannot solve. You understand? You are going to smash them once you are very serious with this video. Now question 3 says a car accelerates uniformly from rest at 5 meters per second square. Determine its speed after 10 seconds. Determine its speed after 10 seconds. Now, what did the question ask? The question says a car accelerates uniformly from rest. Remember rule 1. I said that if a body is moving from rest or at rest, it simply means that the initial velocity is equal to what? Is equal to 0. The initial velocity is equal to what? 0. Now, my parameters given to me, we have v, which is the final. We are asked to solve for it. Then my a, which is the acceleration, is 5 meters per second square. Then my time is t, which is 10 seconds. Now in this question, you'll be asking which formula am I going to use? Now look for the formula, look at the formula. Which one suits these parameters here? Which is what? Equation 1. Because u is equal to 0. Because it is moving from rest. They said it is moving from what? Rest. And even they said brought to rest. It simply means that this is going to be equal to 0. Inculcate that rule into your memory. Now, inputting all this, we have v. We have v, which is our u is 0 plus a is 5 multiplied by our t. Then we have v is equal to 50 meters per second. Do you understand what I did here? 50 meters per second. Now, which one is the correct option here? Option A. Once you master all these things, you are going to solve question neatly. And I will advise you to do this. Yes, I will advise, because this is the easiest way to learn. I have solved up to 3 questions now, and I'm going to be solving more. Now, the question will appear on screen once I read it. Pause the video. Do you understand? Solve the question yourself. Once you are done solving it, then you now play the video to know if you are correct. That is the easiest way to learn. Like, to be honest with you, that is the easiest way to learn. So there is zero harm in failing. Nobody will beat you. Do you understand? Nobody will beat you. That is the easiest way to learn. Now let's look into question 4. Question 4 says a body starts from rest. A body starts from rest and accelerates uniformly at 5 meters per second square until it attains a velocity of 2 meters per second. Calculate the time taken to attain this velocity. Now, this question is also the same thing with this result, because they said a body starts from rest. It simply means start from rest. Our initial velocity is going to be what? 0. Do you understand? And accelerate uniformly at 5 meters per second. Our A is what? 5 meters per second. 5 meters per second. Then, and it attains a velocity of and it attained a velocity of 25 meters per second, which is our normal velocity, which is 25 meters per second. Then calculate the time taken to attain each velocity. Now we are looking for the time, which is unknown. What formula are we going to use? We are going to be making use of this. Do you understand? We are asked to get for C. Now what am I going to do? Our V is 25. 25. Our U is what? 0. Plus our A is what? 5. 5 multiplied by what? T. Then I have 25 is equal to 0 plus 5t. Do you understand what I'm trying to do? Yes. Now, excuse me. The next thing I'm going to do, I'm going to collect like 10. Excuse me. Now, once I collect like 10, it is going to be what? 25 minus 0 is equal to 5t. Then, I have my t is equal to 25 divided by 5, which is what? 5 seconds. You understand? Very neat. Copy down neatly in your notes. Now, let's look into the question to know which one is correct. We have option B to be correct. So, our advice, if you are lying down to watch the video, like I'll tell you the honest truth, you are not going to learn anything. Pick up your book, pick up your biro, get a calculator. Once I'm doing the calculations, you are going to be doing it yourself. Now, question 5. We are going to be solving up to 8 questions or 9 questions, and we look into equations of motion under gravity, because I'm going to be dissecting everything you need to know under rectilinear motions. Now, question 5, it says a train has an initial velocity of 44 meters per second and accelerates and an acceleration of minus 4 meters per second. Calculate its velocity after 10 seconds. Calculate each velocity after 10 seconds. Now you can look at the question. The acceleration is in a negative form. And remember when I said what I said in rule 4, that once you see an acceleration in a negative form, it simply means it is retardating or reaccelerating. Deaccelerating, sorry, not deaccelerating. It is retardating or deaccelerating. So it simply means that the acceleration in this question is retardating. That is why it is in a negative form. Now, let me use my blue marker, and once we solve this, we are going to wipe the board up. Now, we have it to be the parameters given to us. Our initial velocity, which is u, is equal to 44 meters per second. Then, an acceleration of a, which is minus 4 meters per second. Then, meter per second square. Then we have the time to be 10 seconds. Now, you're making use of this to our normal formula. We have V is equal to U plus AT. We are solving for the final velocity, which is calculate each velocity after 10 seconds. So it is going to be, our final velocity is what? V. We are solving for it. Our initial is what? 44. Then we have plus, minus 4. Yes, minus 4 multiplied by our t, which is 10. Now, once you do this, V is equal to 44. Then plus times minus will give us what? Minus. Then 4 times 10. 4 times 10 is what? 40. No need of putting this bracket. Then you subtract. Our V is now what? 4 meters per second. You are done. So the correct option to this question is option D. Now let's wipe up the board so you can have enough space to solve the remaining questions. Alright, number 6 question. A body accelerates uniformly from rest at the rate of 3 meters per second square for 8 seconds. Calculate the distance covered by the body during the acceleration. Now this question is very, very tricky, because they said a body accelerates uniformly from rest, and we are going to be making use of another different formula. But before we do that, I want us to get the parameters first. Now the formula says, or the question, sorry, says a body accelerates uniformly from rest. Our initial is what? Is 0. Then from rest at the rate of 3 meters per second, our A is equal to 3 meters per second square. Then our time is what? 8 seconds. Then calculate the distance covered by the body. Now looking at this particular thing, which formula are we going to use? We are not going to be using this. Do you know why? We are like the question they gave us time. This time is not included. So we are going to be making use of this. Do you understand? We are going to be making use of this. Now, which is S is equal to ut plus half 80 square. Then our S, U is what? 0. So no need of me. Like this is the simple trick I will give you. Once they give you question and they say that the initial velocity is moving from rest, yes, is moving from rest or at rest, and you are making use of this particular formula equation to solve, my brother, don't go and just be multiply, because since it's used at rest, anything that multiplies time is 0. So no need of it. I'm just going to be writing 1 over, this is what I'm going to write, multiply 1 over 2, which is 80 squared. This is what I'm going to be doing. Do you understand now? Because no need of me writing this again, because it simply means this is at rest. 0 multiplied this is 0. So no need of me doing that particular word calculations. Now I have it to be 1 over 2. Then my acceleration is what? 3 multiplied by 8 squared. And 8 squared is what? 64. Then you multiply 8 into 2 is 64, yes. So let's multiply. We have 64 multiplied by 3. 64 multiplied by 3, which is what? 192. Now, I want to give you an easier trick. Coming to this is how I normally use, like this is how I use anything 1 over 2. In 1 over 2, I use it as what? 0.5, because 1 divided by 2 is 0.5. I normally use what? 0.5 to avoid confusion. You understand? So if this is me, I'll come here and just write 0.5. You understand? Since I already know that 1 divided by 2 is 0.5. So it is still the same thing if you also use the same thing. No problem. Now 192 then multiply by 0.5. 0.5, which is what? 96 meters. So now if you want to use this particular thing to solve, now I'm going to give you the trick. The thing here is this. This will divide this, and I will have what? 1 multiplied by 3 multiplied by what? 8. Then we have 8 multiplied by 3. 8. 2 divided by this is not 8. 2 divided by 64 will give us, 64 divided by 2 will give us 32. Now 3 multiplied by 32 will give us 96. It is still the same thing. 2 divided by this is 32. Do you understand? It's not 8, because I knew the square root of it. So I hope you understood this, and the correct option to this question is option E, which is 96 meters. So now let's look into question 7. We are going to be solving a lot of questions, and the remaining question I'll give it to you for you to solve for me, because I'm not going to be solving everything, because I want you to understand what I'm trying to do. Now this question says a particle starts from rest and moves with a constant acceleration of 0.5 meters per second square. Calculate the time taken by the particle to cover a distance of 25 meters. So now looking at this question, we are not going to be using this. We are going to also be using this. You understand? Because in the question, we are asked to calculate for the time. We are asked to do what? Calculate for the time. So now let me just fling my marker. We have the U 0. It starts from rest. Then and moves with a constant acceleration of 0.5 meters per second square. And a distance, which is x, is equal to the distance x, which is 25 meters. Then we are asked to get the time. So plugging it inside this particular equation, we have 25 is equal to, this is 0, no need of me writing it. I'll now write 1 over 2. Then my A is 0.5. Then my T is squared. You understand what I'm trying to do? Then I have 25 is now equal to, remember, 0.5 multiplied by 0.5 T squared, which is going to give me 0. I think this is 0.025. Wait, let me multiply. 0.5 multiplied by 0.5 is 0.025. Then I have 25 is equal to 0.25 T squared. Now what am I going to do here? Listen. Then I have T squared is now equal to 25 divided by 0.25. 25 divided by 0.25. I have it to be what? 100. So T squared is now equal to 100. Am I going to leave it like this? No. I need to cancel like this squared, because in this equation, in this, like, normal time is not squared. Do you understand? I'm not referring you to this equation. In normal quantity, time, they did not say that time is squared. Do you understand? I'm going to be removing this squared. That is where I'm going to be having T is now equal to the square root of 100, which is what? 10 seconds. You are done. Then the correct answer to this question is option C. Option C is correct. Now let's solve question 8. Let's solve question 8. And I think this is going to be the last question I'll solve under this. Or let me finish it up. Yes, this is the last question I'm going to be solving under this. 8 solid questions on equations of linear motion. Now, this question 8 says a body accelerates uniformly from rest at 2 meters per second. Calculate the velocity after traveling 9 meters. A body accelerates uniformly from rest at 25 meters per second square. No, not 25. At 2 meters per second square. Calculate the velocity after traveling 9 meters. Now, what am I going to do here? What formula am I going to use? They said we should get the what? We should get the velocity. Now, what formula am I going to use? Let me write out the parameters. I have acceleration, which is 2 meters per second square. Then my distance, my v is unknown. My u is 0 from rest. Then my x is what? 9 meters. I'm going to be using this formula. You understand? Yes, I'm going to be using this formula because we, like in the question, they didn't include anything like time. So I don't have any business with this. I have only business with this particular guy. You understand? Now, v, which is my v square, I'm looking for it. V square is now equal to 0 squared, then plus 2 times 2 multiplied by 9. Now, my v squared is equal to, no need of me writing 0 because this is already 0. So I have 2 times 2 is 4. Then 4 times 9, 36. Then the square root of 36 is equal to what? 6 meters per second. Do you understand what I did here? This is 0. 0, the square root of 0 is 0. You simply saying something like 0 multiplied by 0 is 0. Do you understand now? So the answer is what? 6 meters per second. 6 meters per second. Now let's look into the question to know which one is correct. Looking at this question, option C is what? Is correct. Option C is what? Correct. Now if you look at this question, they wrote 36 meters per second. Somebody might finish solving and because the person see the question in this particular option, the person will go and rush and tick 36. Do you understand? That is why I normally said you know the formula, but you not arrive at the answer because you don't read the question carefully. You need to read question carefully upon carefully, because you can see how I read this question to do what? Avoid anything like mistake. Now we are done with this equation of linear motion and we have solved complete 8 solid questions, and trust me with full confidence that you can smash any question that comes your way in these equations of linear motion. Now the next one we want to look into is equations of motion under gravity. Let's look into equations of motion under gravity. Equations of motion under gravity. Now we are going to be looking into the equations, and we have 3 equations under this. Now this is the easiest way to know this equation. Number 1 equation is this. Here I have v is equal to u plus a, which is the acceleration. Since they said gravity, I'm going to be doing what? Replacing this acceleration with what? G. That is where I have v is equal to u plus gt. Equation 1. You understand? Equation 1. Now in this one, I have v squared is equal to u squared plus 2gh. Equation 2. Do you know why I said height instead of distance? Is this because we are because since this is gravity is dealing with what? Height. Do you understand? Acceleration is dealing with what? Distance. No difference now. Acceleration is dealing with distance, gravity is dealing with height. Then the next one is this. I have, since this is s, I'm going to be replacing it with what? H. I have h is equal to u t plus half what? Gt squared. I hope this is well understood. Yes. Now we stopped at rule 4. I'm going to be giving you another rule to note under equation of motion under gravity. Right. Make sure you are writing. Now the first rule says that when the body falls freely from a height, it simply means that the initial velocity is going to be what? 0. U is equal to 0. When an object falls freely from a height, they'll give it to you in a question that an object falls freely from a height, then do this, calculate this, so and so on. Do you understand? Make sure you capture that word, falls freely from a height. Now number 2, at maximum height, they must give you at maximum height, because we are going to be solving question. You see what I'm trying to say. At maximum height, v is equal to 0. At maximum height, your final velocity is what? Is 0. Now the next one is this. Which this one is what? Rule 5. Rule 5. Then rule 6. Remember, 12 rules. Then my rule 7 is this. When an object is moving downward, it simply means that the gravity is going to be in a negative form, which is, if it is moving downward, A is equal to what? In the negative form. Then if it is moving upward, it simply means that my A is going to be in a positive form. Rule 7. Rule 8. Now I want you to take note of this. In a question, they might not give you your gravity. If they didn't give you your gravity, it simply means that your gravity is going to be what? 9.8 meter per second square. But in a case maybe you were given gravity to be 10 meter per second square, in the question you use 10. But in a question, if they didn't give you that gravity, you make use of what? 9 meter per second square. Now we are in what? Rule 8. Now let's solve questions under this. So let's solve 1 or 2 questions and we look into this. Now the question says a bullet fired vertically upwards reaches a height of 500 meters, neglecting air resistance. Calculate the magnitude of the initial velocity of the bullet. Now looking at this, we have keyword here. Moving upward, our what? Our A is going to be what? Positive. Now it says reaches a height. Remember when you say reaches a height, it's simply saying that reaches a maximum height. And remember when I said when an object reaches a maximum height, your v is what? 0. Remember this rule. Make sure you do what? Know this rule. Write down these rules in your notes. Write down these rules in your what? Notes. Now, before we solve this question, something skipped my mind when we are solving questions under equations of linear motion. And I want you to take notes and pen down this point. When you have something of, once you hear in a question, how far? Do you understand? How far? They're simply asking you to get the distance. How far? The distance. How long? The time. How long what? The time. You understand? Then how fast? The velocity or speed. How fast? The velocity or speed. So I want you to take note of this point, because question might come in this way. They might ask you after this, then calculate how fast will the vehicle move. Then you will now wait to how, what did they ask me to get? Do you understand? This is the key point you need to take note. How fast, velocity or speed, how long, time, then how far, distance. I hope this is well understood. Now let's solve this question. We have our g, which is in a positive form, plus 10. Then our v is 0. Since it is in a maximum height, it reaches a maximum height, it's 0. Then we have our height is what? 500 meters. Then we are asked to get the initial velocity. Then looking at this question, which one are we going to use? We're looking at this equation. Which one are we going to use? In this question, we don't have time. So we are going to be looking at the one that don't have time. So we are going to be making use of this. You understand? Since time is not included in the question. Now, substituting, our v here is what? 0. Then, my u, we are looking for it. Then, plus 2 multiplied by 10 multiplied by 500. Do you understand? Multiply by what? 500. Now let's substitute. We have 0 squared is now equal to u squared plus 2 times 10 is what? 2 times 10 is 20. 2 times 10 is what? 20 multiplied by 500. Let's substitute. 20 multiplied by 500 is what? 10,000, which is u squared plus 10,000. Now, what is the next step? I will collect like terms, which is u squared is now equal to this squared is 0, which is 10,000 minus 0. Then I have u is now equal to the square root of 10,000. Then the square root of 10,000 is around 100. Let me do it. Yes, 100. So it simply means it is what? 100 meters per second. The initial velocity is what? 100 meters per second. Now let's look into the question to know which one is correct. So option B is what? Is correct. You can see, always read the question very, very well. Very, very well. Because if you don't read this question very, very well, you will not understand what they are trying to say. Do you understand? And also inculcate this rule. I repeat. Now question 12. We are going to solve up to 2 questions. Then we move into 2 or 3 questions. We move into the next thing. So question 12 says a bullet is still the same thing that we solved. A bullet, not question 12, because we have not reached 12. So the next one is, if it takes an object 3 seconds to fall fully to the ground from a certain height, what is the distance covered by the object? Ha! Jesus. Now looking at this question, they say distance. You can see they want to confuse you. Remember when I said that distance in equations of motion under gravity, distance is being replaced with height. So don't get confused. Now looking at this question, you say if it takes an object 3 seconds to fall freely. Since this particular object is falling freely, it simply means that this my u is going to be what? 0. It is falling freely, u is what? 0. My initial velocity is 0. Now looking at this, I'm going to be using here. So I'm going to be using which formula? I'm going to be using this particular formula. Since in this question we have time and also we have d, yes, we are going to be using this. And we are asked to get the distance, which is what? The height. You can see how this tricky, like you can see how tricky this question is, which is what? H is now equal to. Am I going to be writing this again? No. Like, understand what I'm trying to say, because since this is 0, I'm not going to be writing it again. I'm going to be writing it as 1 over 2, then gt squared. Since this is 0, then I have h is now equal 1 over 2 multiplied by, look at the question. They say if it takes an object to fall freely to the ground from a certain height, what is the distance covered by the object? Okay, now let me ask you this question. In this question, will our gravity be positive or negative? Our gravity is going to be what? Negative. Why is it going to be negative? Look at this question. It says it takes an object 3 seconds to fall freely to the ground. It is falling downwards, so it is not going to be positive. Do you understand now? Multiply by minus 10, then my seconds is what? 3, then 3 squared. Yes. Then the next thing I'm going to do is what? H is now equal to 3 squared, which is 0.5 multiplied by 3 squared is what? Is 9, which is 10 multiplied by 9, which is minus 10 multiplied by 9. So I have h is now equal to 9, 10 multiplied by 9 times 0.5, which is 45 meter, which is what? 45 meter. Now let's look into the question to know which one is correct. Option C. Do you understand? Remember what? That this is what? Downward. It is what? Negative. Do you understand? Since this is going to be minus 45, but since the question is not in a negative form, do you understand? We are going to be writing it what? In a positive form and get the correct answer. Since the option is in the negative form, we are going to pick the negative form. You understand now? Now let's solve question. Is it question 14? No. I think yes. Now let's solve question 14. Now let's solve the last question. The last question says a bullet fired vertically upward from a gun held 2.0 meter above the ground reaches its maximum height in 4 seconds. Calculate the initial velocity. Now I want to explain this. Just calm down. Is not every parameter is given to you in the question you must use. Why did I say so? Listen. If in any question given to you and it obeys any of these rules that I've listed, do you understand? The rule is being attached, but the parameters is also given to you. Do you know what you are going to do? Omit that, like your main focus rather should be on that rule. Now looking at this question, we are given time, and also they already said maximum height, in which our final velocity is going to be what? 0. But how can I solve with c? Do you understand? The thing here is you will need that c, because that c is a confusion to you. Or you're like, what you are interested in is the rule. Simple. Do you understand? The rule. Make sure you know this rule. Now looking at this, they said the height is maximum, which is at maximum height, and our velocity is going to be 0. Now which formula are we going to use? This, because we are asked to get the initial velocity. Do you understand? We are asked to get the initial velocity. Now it is going to be what? V is equal to u plus gt. Now my v is what? 0 is now equal to u plus. My g is what? 10. Since it is moving vertically upward, it is not moving downward. It is in a positive form. Multiply by, my time is in what? Is in 4 seconds. You understand? My time is in what? Is in 4 seconds. So since they said maximum height, do you understand? You don't have any business with the height. Since they already said that it is in what? The height is maximum, and we need to respect this velocity, which is what? 0. So sorry for saying that you should omit this the time. No, it's not the time that you are going to meet. You are going to omit the height. You understand? Because the question says at maximum height, and you already know that the velocity is what? 0 at maximum height. So I hope you understand to this part. Then I have 0 is now equal to u plus 40. So I'm going to making this particular subject of formula, which is u is now equal to 40 minus 0, which is u is equal to what? 40 meter per second. So it is not in, like, it's not every parameter is given to you in the question you must use. You need to do what? Your main interest should be in this rule. We have listed up to rule 8 when we treat this distance in time interval and velocity time graph. You understand? You understand all this particular thing, which is what? 12 rules in rectilinear motion. Now let's look into this particular distance in time interval. All right, so we have done definition of this. Then we are already in the distance in time interval. So I want you to pay maximum attention here, because students normally fail this. You understand? Yes, students normally fail this, and I'm going to be doing what? Explaining this to a layman understanding, that you yourself, once you feel like, once you see questions on this, you feel like you feel normally. You understand? It's not something that you'll be very, let me say, like, you don't have confidence in yourself to solve the question. So I'm going to be explaining it. Now, distance in time interval. Now, in this particular distance in time interval, we have formula to solve, and I'm going to give you the shortcut formula to solve. Because anything exam, you understand? Anything exam, you need something that will be very, very easy for you to solve. And to be honest with you, if you know the shortcut, but you don't know the main formula, you will continue failing questions when questions come from that particular what? Topic. So it is not something that I will advise you to go and be learning shortcut. No. Always know the roots, the formula for that particular thing, and also apply shortcut. Because once you just go and dive into shortcuts, once you see question, you will still fail it. You understand? Now, in this distance time interval, we have, this is the main formula, when we have S is equal to U plus A over 2 into bracket 2t minus 1. Now, this is the shortcut. We have two formulas for shortcut, which is S is equal to what? 1 over 2 A bracket T2 plus T1. Now, this one is my simplest one I normally use. Then this is the third one, which is 1 over 2 A bracket T square, which is 2 minus T square 1. This is it. So you can make any use of this and solve, you arrive at the same answer. And we are going to be applying it here. Now, I want you to take note of something. Yes, I want you to take note of something. But let me read out this question. Then I will now give you the rule for this distance in time interval. We have, I think, 2 rules in this distance in time interval. Now, let's examine this question. Right. It says a body starts from rest and moves with a uniform acceleration of 6 meters per second square. What distance does it cover in the 30 seconds? You can see what distance does it cover in the 30 seconds. This is what we call distance in time interval. Now, I want us to take something, like I want us to write something. Like you'll be asking, why didn't I use UT plus 1 over 2 and then write this? Do you know why? Coming to time interval, coming to the questions that I've seen so far, the initial velocity is always at rest, which is what? 0. So that is why I don't bother writing UT. No. Do you understand? So anything multiplied by 0, I have said it. You understand? Now looking at this question, they said a body starts from rest and moves with a uniform acceleration of 6 meters per second square. what distance does it cover in the 30 seconds? Like I'm going to dissect everything. Follow me. Now looking at this, I have my T2, I have my T1. Now in this question, I have only one I have only 1 second, only one time or 1 second. Anyone can go since they are the same thing. I will use time. I have only seen one time. But how can I get the next time? It is very, very simple. Listen. The time given to you in a question is your what? Is your final time. What do I say? The time always given to you in distance time interval is your final time. Now, how do I get my what? My initial time. Now, imagine you have 5. Your initial time will be what? 4. Imagine I have 3. Your initial time will be what? 2. Imagine I have 100. Your initial time will be what? 99. That is how it works. Now, looking at this question, we are asked to get the distance in the 30 seconds. Now, I'm going to be applying this person first. After using it, I'm going to also use this to solve, to know if we are going to arrive at this. And take note, in this particular thing, even though they will give you something like time, 10 seconds in a question, but they gave you 10 seconds, or they will give you 4 seconds, 100 seconds, or even 1,000. You don't have any business with that second. That says 10 seconds given to you. Your mind should be in that either 10 seconds, 4 seconds, 5 seconds. You don't have any business with it. I'm going to give you when you have business with this particular thing. This is rule 9. I've listed rule 9 now. The rule 9 of this stated that in a question given to you, even though you are given something of 10 seconds, 9 seconds in the question, but the question says in the 3rd seconds, in the 5th second, in the 6th second, your main concern is in the what? In the end seconds, which is the what? The 10 seconds, the 4th seconds, the 5th seconds, and so on. I hope you grab it now. Now, this is what? Rule 9. Write it down. Pause the video and write it down. Now, looking at this question, I'm going to be using this particular guy first, so you can understand what we are doing here. It's not magic. I have S is now equal to, since it is at rest, 0 plus our acceleration is what? 6 divided by 2. Then 2 multiply, our time given to us is what? 3. Multiply by 3, which is they said 30 seconds minus 1. Then I have x, excuse me, minus 0. S is equal to 0 plus 6 divided by 2. Then into brackets, 2 times 3 is what? 6, which is 5. Now I have S is equal to 3 multiplied by 5, which is what? 15 seconds. I've used the equation 1 to solve. Now let me use this. I have S is now equal to 1 over 2 multiplied by my acceleration here is what? 6. Then my first time is what? 3 plus 4. Do you understand? 3 plus 4. Then I have, is it 3 plus 4? No, it's not going to be 3 plus 4. It is going to be what? 3 plus 2. Sorry, they said in the 30 seconds. My first is what? 3, and the initial is going to be what? 2. So I have S is now equal to 1 over 2 multiplied by 6. Then multiply this plus this is what? 5. Then I have S is now equal to 1 over 2 multiplied by 30. This into this is what? S is equal to 15. 15 seconds. 15 meters, sorry. This is meter, not seconds, because it is what? Distance. You can see it is no magic. Even though you use this particular the same thing, it is still the same thing. You understand? So I've listed 9 rules. Now let's look into the next one. And this next one, I'm going to be giving you the 10th rule in rectilinear motion calculation. Alright, so we solved question on time interval. We have solved one question on time interval. And I've given you the rule 9 of it, in which when I said that in a question and you are giving the nth seconds in the question and also giving time in that particular question, your main concern is in that nth seconds given to you. Like you don't have any business with the seconds, the time given to you in the question. Now let me read out this question before I give you the rule 10. Now the rule not the rule 10. This question says if a car starts from rest and moves with a uniform acceleration of 10 meters per second, 10 meters per second square for 10 seconds, then the distance it covers in the last 1 second of its motion. Now grab this rule. This rule is this, the 10th rule. When you are giving last 1 second and also giving time in the question, your main concern should be what? In the time given to you. What do I say? I said in a question and you have last 1 second and you also have time given to you, your main concern is on the time given to you. Now this particular rule is only applicable when they say last 1 second. Do you understand what I'm trying to say? Now let's solve this question. Okay, remember we have s is now equal to u plus a over 2 bracket 2t minus 1. Now let's use this to solve, and I'm also going to use the other shortcuts to solve. Now x, u is 0 because they said from rest, plus a, my a here is what? 10 divided by 2, 2 multiplied by 10 minus 1. S is now equal to 10 divided by 5, 10 divided by 2 will give me 5 bracket 2 times 10, 20, which is 19. Then 19 times 5. 19 times 5. 19 times 5 will give me S is equal to 95. 95 what? Meter. So because this is what distance. Now I'm going to be using this shortcut, which is S is now equal to 1 over 2 a bracket t t2 plus t1. Now S is now equal to 1 over 2. My a here is what? 10. My a here is what? 10, which is multiplied by 10 into bracket my t. My t, we have 10 seconds, which is t2. Then plus my t1 is going to be what? 9. Remember what I said. If the final is 10, the initial should be what? 9. Then I have S is 9.1 over 2 multiplied by 10 into 9 into 19. Then 19 multiplied by 10, which is 1 over 2 multiplied by what? 1 over 2. And I have 19 multiplied by 10 will give me 190. Then S is now equal to 190 divided by 2 is what? 95 meter. You can see both of them are the same thing. Anyone that you choose to solve with, you are good to go. Now I want you to do this for me. Okay, I'll change the time to, let me change the time to 9. Let me change the time to 8. And not the time, the acceleration to 8. Then solve and give me the answer in the comment box. I want you to try this so you can understand what we are doing. It's not magic. Do you understand what I'm trying to say? It is not magic. Once you know all formulas in physics, there is no way you will not solve any question that comes your way in physics. That is why I like physics. Once you know the formula, you can solve that particular thing. So it is not complex like chemistry and so on. Do you understand what I'm trying to say? Physics is something that if you know the formula, you can solve. If you don't know the formula, you cannot solve. It is not like mathematics. Mathematics, you cannot know the formula. You can use different methods to solve and get the answer. But in physics, if you don't know the formula, you cannot solve. Now you just make sure that you do this and give it to me in the comment box. Now let's look into velocity time graph. Our interest is going to be here, velocity time graph. So make sure you do what? You know this. Rule 10, which is the next one, is rule 11.